Here's a presentation I gave recently which gives you an idea of what we do. This relates to a project that's in progress right now at Seacrest Country Day School in Naples, Florida. And the title of the presentation that I made to an engineering group was High Quality Media Production at a Surprisingly Low Cost. The library at Seacrest Country Day School had a little alcove about 15 feet deep by about 24 feet wide. It previously was lined with bookshelves and was just kind of a secluded reading area. They decided they wanted to convert this into a green screen based television studio. Not very large, but nonetheless the renovation coming up of the entire library will include hopefully a setup similar to this. Expanding out a bit into the library floor area from this alcove, a control room and a glass front to both the studio and the control room, sort of a storefront type situation, giving it a display or fishbowl type environment where the activity that's going on in the studio and the control room can be observed from within the body of the main library. This will be coming in the future. The school has plans to renovate the entire library, and so the addition of the walls here, whatever form they eventually take, will be a part of that master plan. But meanwhile, while we're waiting for that to be developed, the school wanted to get the equipment together and start using it in this environment, but without the walls, basically, more or less in a portable configuration. In talking with students and with faculty and with administration of the school, we were discussing what the purposes of this particular facility would be, and we came up with a few ideas here. Class training and media production being one, of course, and fairly obvious, but also preparation of media-based reports for other classes, production of a school news broadcast for the student body, that to be done primarily for and by students. For the faculty, production of media for class instruction. If they had a complicated experiment or something that would be difficult to reproduce multiple times, they could record it in advance and use that as media for instruction in the classroom. Recording and evaluation for speech and debate classes. Illustrating the importance of media in any subject. And then for the administration, production of media to promote the school to the public, sort of a PR arm. Production of innovative training materials for other schools as they develop unique curriculum and teaching styles. The opportunity to share that with other schools by means of video was a definite plus for this facility. And production of in-service training materials for faculty and staff. After this discussion, we came up with the concept of 3 cameras, a green screen capable switcher with a touchscreen controller, 2 decks for recording and playback using SD cards, teleprompters, live streaming capability, DMX-controlled LED lighting for the studio once it's completed, and future-proof 4K capability for the entire facility. Although it's being operated right now at 1080p, their full 4K capability is built into the system and can be upgraded just by changing settings on the cameras and the switcher and the recorders at most any time when it becomes appropriate. Again, as we said, 2 phases: immediate use of the equipment deployed in a portable configuration, and then finally permanent installation after the library renovation is complete. An overall simplified look at the configuration of the equipment: 3 cameras going into a switcher, 2 recorders being fed by the switcher, and then their outputs going back into the switcher for playback of pre-recorded material incorporated into a studio setting. A streamer, we'll talk about this later, but allows the output of the switcher to look to a streaming computer just like a webcam. So all of the benefits of a multi-camera production can be output very easily into a streaming format for Facebook, for YouTube, or for other proprietary streaming configurations. And then finally, at the bottom, a standards converter, which will convert video of almost any format input by either HDSDI or HDMI into the format that the switcher is set for at this time. So we say currently it's 1080p, but when that is upgraded, then Other material can be up converted or down converted or frame converted or cropped or aspect ratio converted. Sort of the Swiss Army knife of video equipment, in the fact that it will take almost anything that you can run into it and output almost any format after having converted the input signal. The cameras, we selected the Blackmagic Design Studio cameras, Ultra HD models with the 4K capability. Two of them have teleprompters, as you can see on the lower right illustration. On the upper left is the camera 3, which does not have a teleprompter, so you can see the front end of it a little bit easier. And then a quick look in the upper right corner of the super large 10-inch viewfinder. They are low cost compared to other cameras that have 4K capability. Without the lens, this beauty shot off of the Blackmagic Design website shows the camera priced at $16.95. And there are pros and cons, of course, to most any camera that you might select. For this model, we found the pros to be the 4K capability, the huge viewfinder, tight integration with the switcher, which we'll talk about in more detail later, and a very low cost, comparatively speaking anyway, allowing us to get 3 cameras to begin with for equipping the studio. The cons, the micro 4/3 sensor in the camera is a great asset as far as the 4K capability, but then it takes very expensive lenses to be able to deliver enough light. And the micro 4/3 lenses, which are primarily designed for still cameras, are few and far between. There are basically only 2 models that I've found that have power zoom, which is what we wanted in this configuration. One of them that we got for the studio use is a either wide angle to slightly telephoto, equivalent of, I think, a 20 millimeter to, say, a 90 millimeter lens as far as 35 millimeter equivalents are concerned. There's another one that goes from 70 to 300 millimeter equivalent, but in the micro 4/3 capability. But the larger sensor, of course, requires more light to cover it, and as a result, the light sensitivity of these cameras is not quite what you would find on a lot of other studio-type cameras. However, with adequate lighting in the studio, this is not really an issue, and so these prove to be the ideal camera choice for this particular installation. We mentioned the integration between the camera and the switcher. There are 2 coaxes, one going each way, one from the camera to the switcher, the other from the switcher back to the camera, and all sorts of signals are multiplexed upon these. Video, of course, from the camera to the switcher is the primary one, but there's also 2 channels of audio, an intercom return coming from the camera intercom microphone back to the switcher and the director, and also data return on the settings that are accomplished from the switcher. More on that in a bit. From the switcher back to the camera, we have program video and audio, we have intercom, we have tele, and we have camera control commands. With these particular lenses, which are power zoom lenses, from the switcher control screen back there at the control room, it's possible to, on the camera, remotely control zoom, focus, color balance, gain, black level, and iris. Some of that, zoom and focus and so forth, can be handled by the camera operator as well, but for limited situations, and if a camera which is not manned needs focused, that can easily be accomplished from the control room by means of these data returns. Basically, we made up our own camera cables. It was difficult to find something with 3 coaxes and a power connection already pre-made, and so we used a sheathing. These will open up to allow cables to go in, and then they can be pulled tight to make a nice preformed cable. We use 3 coaxes in our camera cables, the 2 that we mentioned going to the camera and from the camera. The gray cable is used to bring SDI prompter video back from the control room to the teleprompters. And then the power cable goes to a standard 4-pin XLR power connection. And then trailing out of the back of that are 2 little consumer-type power plugs. One goes to the prompter monitor, and the other goes to the converter, which converts the SDI signal coming to the prompter to HDMI, which the prompter monitor requires. It is fortunate and turned out and well selected that the fact that all 3 of the components there at the camera end require 12 volts DC. And so it was very easy to bring a single 12-volt circuit out and then split it off at the camera for the various uses. On the bottom picture, you'll see a little piece of Velcro that is wrapped around and tied with cable ties around the cable close to the camera end. We put some Velcro of the opposite gender on the tripod, and once the cable is attached to the camera, we can stick that to the tripod, which takes the weight of the cable off of the rather small cables and connectors there, so an undue stress is not placed upon them. The entire weight of the cable to the floor is not weighting down upon them. And the inset on the left just shows the relatively small size of this coaxial cable compared to the size of a standard BNC connector to which it's connected. The switcher itself, we used a Blackmagic design switcher as well. This is the 1ME Production Studio 4K. It has 10 inputs. Outputs are program, preview, multi-view, and 3 selectable auxiliary outputs. Talk about those in a minute. Selectable from the front panel. Virtual panel software controller on a separate computer via Ethernet network. The simulated control panel on the computer can actually talk to and control the switcher functions itself. It has an integrated camera and audio controls that we talked about a little bit ago. Integrated remote controls for the recorders. It's possible with the connections back to the recorders to punch up a playback of a recorder on program, and it will start the recorder automatically. There are 4 chroma keyers built in there, which was essential for this installation and some of the things that they wanted to do. And there are then 2 downstream keyers. Those are normally used for lower third graphics, identifying a particular speaker or whoever's on television, and then perhaps a bug identifying the network or the source of the programming. Those can be controlled independently. The control software we decided to install on a desktop, all-in-one touchscreen computer, and that has worked out very well. It simulates the layout and the action of a hardware control panel, but we just chose not to get a hardware panel, at least at this point, due to the expense. As you'll notice, the switcher was fairly low cost, but the control panel, hardware control panel, to actually operate it with physical buttons and a fader bar and all of those controls was around $5,000. And so we decided to forego that for the time being and to use the touchscreen computer to be able to control that. There are also, normally, if you didn't have a touchscreen computer, you'd operate it with a mouse, clicking on the various inputs as needed. But there are also keyboard shortcuts, which are handy in this case. The number keys select the input on the preview bus, and then the space bar is the cut control between there. So for simple productions, you can actually operate the entire switcher by means of the keyboard connected with that computer. A separate screen on the software brings up camera controls, and they're pretty sophisticated compared to a lot of camera controls on studio cameras. The little circle there with the lines going out up and down and left and right towards the bottom is the iris control and the black level or setup control. Moving it up and down opens the iris on the camera for more light. Moving it to the left and the right adjusts the black level or black settings of the picture. But then up above it are some very sophisticated color balancing and color matching controls for lift, gamma, and gain, and the ability to adjust those separately and tint those separately in different directions to provide a very precise match between cameras, or even generate some special effects that you might want to that relate to color. And then the black strip along the middle has settings that are easily accessible for gain, 0 up to 16 dB, and shutter speed, ones shown there are at a 50th of a second, and then color temperature. You can adjust those in steps. These cameras do not have a point at a white screen and push a button type white balance control, but basically they have steps of color temperature at about 200K increments, basically, and so you can just step up and down until the color temperature setting on the camera matches the color temperatures of your actual light fixtures. Also, another tab on that same controller is the audio panel. The cameras, as we mentioned earlier, can bring audio back. Each camera has a built-in microphone, which isn't very good, but it also has 2 XLR microphone inputs with phantom power as needed, and XLR microphones can be plugged into those or other XLR sources and brought back through the camera cable and into this mixer. You see those set up like camera 1, camera 2, and camera 3. The switcher can also be set up for audio follow video, so that whenever a particular camera is taken on program, its microphone or its audio opens up, and when you go off to a different camera, then that audio closes down. That's a little impractical for studio setup usually, but if you did have a remote camera way off somewhere for a long-distance report, being able to turn that microphone on when the camera was switched on and then off later would work out okay. And those can be individually set up on each one of the channels. We generally, in our setup, do not use these. We have a separate audio mixer that you'll see in a little bit, and it comes in on the next to the last right-hand side labeled XLR. There are 2 XLR audio inputs on the back of the switcher, and the output of our external mixer, which mixes our microphones from the studio, comes back in through this one input. The mic input to the left of the XLR is replaced on ours with what's called an RCA input. There are a couple of RCA jacks on the back where you could, with an adapter, plug in an iPod or some other source of music, a DVD player or whatever, and have that input available there as well. Of course, the master on the right with the audio meters on each individual input as well as on the master. There's our external audio mixer that we used. We have a snake that runs from the studio into the mixer board carrying 8 XLR inputs. There's only room for 6 on the board. And then on the right you see the audio outputs, which are running to the XLR input on the switcher. Here's the recorders, and they are very interesting. For one thing, they're fairly inexpensive for 4K capable recorders. They record on SD cards. You see 2 slots there for SD cards on the left. The capability is there to start a recording on the first card on the left. When that one fills up, if you've got a blank one in slot number 2, it automatically transfers over and starts recording on there, giving you an opportunity to take the card out of slot 1, put a blank card in there as well, thus the ability to record continuously on these units. Also, they have the capability, as I mentioned, of being remote started from the switcher itself. And also, interestingly enough, each recorder has a built-in FTP server. Basically, what that means is that you can transfer files, pre-recorded files, in and out of this unit by means of the Ethernet network. You do not have to take the card out and stick it in a card reader and record or transfer files to it. You can actually do it over the network and transfer them into those cards. As you can see, these things are very, very small. This is an 1 3/4 rack height, and it's 1/3 of a rack width. And so you can actually mount 3 of these things in a single 1 3/4 rack unit. And so it's enlarged here, I guess, to show the detail. Another unit that looks very much like it, and it occupies the 3rd slot in our 3-slot rack panel unit. This is called the Web Presenter, and as I alluded to earlier, it takes the output from the studio, whatever you've switched, whatever graphics you've built and created, the program that you're doing in the studio, and it converts it to a USB signal, which can plug into a computer, laptop, or otherwise, and it looks just like a webcam, which means that streaming software could be done for Facebook or YouTube or Vimeo, or even proprietary streaming software can see this just as though it's a webcam, and can therefore stream out all of the capability that you have in the studio very simply and without a lot of extraneous conversion boxes and things like that. Here's the front panel of the Swiss Army knife that I was telling you about, the Teranex Standards Converter. Basically, it will take anything you can throw it, practically, either as an SDI format or an HDMI, and then we'll convert it to most anything that you want. Up convert, down convert, aspect ratio convert, frame rate convert, just about anything that you want to do with something. You can put it in there and you can make it come out in the format that you want. Here's an example of the connection diagram that we're delivering to the client. It's nice that Blackmagic Design website has these back panel connection diagrams available on their website, which we downloaded and combined with various connections. So not only are the wires numbered, and we have a separate sheet that describes the function of each one of those wires and where they go to and where they come from, but also can be illustrated here in a very graphical sense, that you can see where wire number 9 goes, and that the blue and red are all SDI video, and the blues, we adopted the color code. It makes it easier to read the diagram here as well. But the inputs to the switcher, which is the top panel there, are blue, and the outputs of the switcher are red. And that can get a little confusing on some other devices where camera studio outputs are actually inputs. So the standard was adopted for the switcher itself, and then let everything else fall where it may. The green are USB, the blacks are HDMI, and the gray cables are only 2 of them basically. Well, there's 3. One of them doesn't go anywhere, but the other 2 go to the teleprompters on the cameras. The Ethernet connections all go to a common switch, and to simplify the diagram here, we just marked those in purple where they plug in and labeled them Ethernet. So there are 1, 2, 3, 4, 5, 6 elements here that connect to the Ethernet and can talk basically to one another. And also, of course, out of the streaming laptop goes out to the place where the streaming is to go, whether it be Facebook, YouTube, or wherever. So this just it makes it easier for maybe people who aren't quite so technical to be able to see where the wires go, and if something got disconnected, to be able to reconnect it to the proper port, since there are a lot of connections on the back that aren't being used in this case. Talking a little bit about lighting, we went with lighting by a company called Dracast, LED lighting. All of these fixtures are able to be controlled by computer via DMX protocol. We decided to opt with just daylight balanced fixtures. They also make fixtures which can be adjusted between daylight and tungsten, but we just, those were more expensive, and we figured there wasn't much need to do that type of balancing, that we were going to adopt daylight equivalent for lighting for within the studio. This is a flat panel 1 foot by 1 foot soft light. It has a 1,000 watt equivalent output, but it takes just a little bit over 100 watts of electrical power. We purchased 3 of these units. We also purchased 3 of these units, which are a little bit more sophisticated. They are focusing Fresnels, but also LED powered. This is a 1,500 watt equivalent with about 160 watts of power input. Again, DMX controlled. The big black knob on the back of the unit adjusts and slides the light source backwards and forwards in behind the lens that is on the front of the unit, which allows the light to be concentrated into a fairly small spot or flooded out into a fairly wide flood area. Of course, the small spot with more light concentrated on it is brighter, and so therefore a certain amount of intensity adjustment can actually be made just by flooding the light out or moving it more towards the spotlight position. So we ordered 3 of these fixtures, and then there are 3 smaller ones that look just like this. They're 700 watt equivalent, and they are primarily going to be used for backlight and highlight, highlighting the back of the subjects there in the studio to provide some separation between them and the background. So 9 fixtures altogether in that small space. We may eventually need some more, but until it's constructed and we find out exactly how the physical space is going to be used, we thought this would be adequate to begin with. The fly pack setup that we have that they wanted done to make the unit portable for the time being, as you can see, the units haven't been prettied up there yet. This was still in the process of construction, but a power surge protector, power control at the top, the switcher next down, the intercom and connection unit that we haven't talked about, but it is an essential part of getting the intercoms connected to the various cameras. And then below it, the 3 panels that we are talking about. The 2 on the left are the recorders, and the one on the right is the web presenter converter, the converter that converts the studio output to USB. And then on the bottom is that magical piece of equipment that I call the Swiss Army knife, the Teranex standards converter. The unit that we selected for the roll-around case is kind of interesting too, because it has on the back panel of the unit, the back cover, that you can cover it up when you're transporting it, but you take that cover off, and folding out from the inside of that cover is a leg. And on the side of the switcher are a couple of clips that can hold that back door, and with the leg supporting it on the far side, which is outside of the picture here, unfortunately, but it becomes a table that you can put some equipment on right next to your fly pack containing all of the hardware that's required to make the thing operate. So as we come to the conclusion here, the project is about halfway completed. The remaining thing that needs to be done, as we mentioned, was the complete renovation of the interior of the library, which will provide the walls and the necessary location for permanent installation of the equipment that is currently deployed in a portable configuration. So that is a project yet to come, but we're in the space right in between right now, where the students are getting a lot of experience using the equipment, and we actually rolled it into the gymnasium the other day to be able to shoot an awards presentation and a talent show that they were having in there. So the portable configuration is serving them well right now. But once that is finished, then we'll have permanent installation of the control room equipment. We'll have curtain tracks with 2 of them going around the 3 walls that are now currently green. They will have a black and a gray curtain that we can pull in front of the green wall in case we don't want to use green screen backdrop. And then a pipe grid with hanging fixtures under DMX control. These fixtures that we have that are now mounted on light stands will ultimately be suspended from the ceiling and be controlled from the control room, computer controlled by their intensities by means of DMX protocol connections. And that concludes the presentation that I gave recently, just an idea of what we do and the size and the scope of some of our projects. Thought this one was a good one to make an example of, to illustrate basically what we do and how we go about doing it. So thank you for watching, and we'll look forward to presenting some future projects as they become available.